Hi, today we're going to continue with sequences, but this time, if you look at our use what you know problem, we are not given the terms like right in a row. So on our first problem, we're given the second term is 7, and then we're given that the fifth term is 19. And our goal is to figure out all the other terms that are listed. All right, well, first they have to tell you what type of sequence it is. Otherwise, it would be kind of impossible. So they're telling you on this problem that it's an arithmetic. And you know that an arithmetic means that you're adding the same number. So basically, if we can figure out what the number that we're adding is, then we can figure out all the other terms that we need. All right, so how would we do this? I mean, you could sit here and try to guess. Like you could guess 7 plus 2 is 9, plus 2 is 11, plus 2 is 13. Nope, it should be 19. That's not it. So let's try 4. That's 11, and 4 is 15, and 4 is, oh, I got it. Now, that's only if the number's nice. Remember, numbers can be negative. They can also be fractions or decimals. So what else could we do to figure out the answer besides just guessing? So again, this is where we bring in algebra. Anytime you have an unknown, we use a variable for that. So 7 plus the common difference, or you can use an x, plus the common difference, plus the common difference has to get to 19. So if you can write that, you actually have the equation that you need to use to solve staring you in the face. It's 7 plus d plus d plus d is 3d's equal 19. And then at this point, you have something you can solve. Again, you could guess and check, but it's not always going to be that easy. And there we have our d is 4. Okay, so once we know d is 4, we now can write all the other numbers that we need. So 7 plus 4 is 11, which you already had, plus 4 is 15. We know that that's 19, plus 4 more is 23. And then to get to our 10th, we could keep on adding 4, but remember, we want to always try to simplify our life. So keep on adding to get to 50th would be tedious, like we already described last class. So in order to get to 10th and 50th, we always want our home base number. So if you add to go this way, then to go backwards, you would subtract. So that means I know my first term would be 7, take away 3, or 4, excuse me, which would be 3. So that's my home base number. And then from there, I can use what we learned last class to find the 10th number and the 50th number. I know that the 10th number will be our initial number 3, our first one, plus I know that I'm going to add 9 4s, because remember, it's always one less 4 than you have numbers, so the 10th number would only require 9 more 4s, and then I can just use that to figure out this number, and that's going to be 39. So to get up to the 50th, I have all the information I need now. So to get to the 50th, I know I'm going to start with 3. And that I know to get to the 50th, I'm going to have to add 4 49 times. So it's going to be 49 4s. Use my calculator for this one. So that means that number will be 199. Okay, we'll try one more together, and then we'll do our notes. Okay, so for this one, it's the other type of sequence. It tells us that we have a geometric sequence. Now, a lot of times students get confused and want to use what we just used with the arithmetic to try to do it this way. But remember, with the geometric, this means that you are multiplying the same number each and every time. So again, we can either A, try to guess and check. So I can try to guess 2. Let's do times 2 is 12. Let's do times 2 is 24. and times 2 is 48. Okay, again, I got lucky that I got it on the first try. Not always going to be that easy, nor is the number always going to be a whole nice positive answer. So what else could we do to figure out our multiplying number if it isn't that easy? Well, this time, instead of adding to get to each term, we are multiplying, and it's the common ratio. So it's going to be times r. There's some number r I'm looking for that I have to multiply, and I know that I also have to multiply this one by r to get to the next one, and I have to multiply by another r to get to my final number that I know. So I'm going to write this out. We have 6 times r times r times r has to get us to 48. Well, if I simplify this is 6, and r times r times r is r cubed. And then that's the equation that you're really trying to figure out. And at this point, you're just going to use what you've learned in solving. I first want to get the 6 out of there by dividing. And then in order to get rid of a 3 power, you can do either the cube root or you can do the reciprocal power. Because remember, that's over 1. And then when you do 8 to the 1/3 in your calculator, you're going to get 2. And that's the number we already knew was the answer. So again, filling in my numbers, times 2 is 12, times 2 is 24. Now I know times 2 is 48. I can do another times 2 is 96. And just like before, if I have to do times 2 to go forward, I have to do divide 2 to go back. So I now know that the first term again is 3. And that's going to help us get to the 10th and the 30th term. So in order to get to the 10th term, which you learned from last class, we always start with our home base number 3. And we are multiplying 2. And the number of 2's that I need to multiply is always 1 less. So there's going to be 9 2's. So that's going to be a 9 power. And now I can figure out the 10th term. So 1,536. And then to get to the 30th term, this will be a rather big number. We start with 3. We know we multiply 2. And we know to get to the 30th, we'll need 29 2's being multiplied. Yep, really big. Okay, so that is our lesson for today. So now we'll do some more problems, just like these ones. All right, so just some quick vocab. You've been dealing with some of these before. When you see a sub 1 is how you say it. A sub 1 means the first term. The lower numbers, those are called subscripts, and subscripts, you don't have any, it's not a mathematical operation. It's like an adjective, like you have brown hair, you have blue eyes. So anytime you see a lower number like this, it just means it's describing. So that A1 means the first term, A2 means the second term, A100 means the 100th term, and then A sub n means the nth term, or whatever generic term you're looking for. All right, so the problems will be given to you maybe in this manner. Given the following information, number 1, sorry, in an arithmetic series, A3 equals 16 and A8 equals 46. Find the common difference. That's always the most important goal, is to figure out what you're adding to help you figure out all the other numbers. Now you can do a visual. So A3 would be the third number in is 16. And the 8th number in is 46. Okay, so we can either do it one of two ways. We can set up our equation. You can sit here and try to guess and check numbers, but again, not always going to be easy. Or I can do this. I know we're going to add D how many times? Let's see. We're adding, for arithmetic, we're adding. So 16, now you can write plus D here. I can do this, plus D to get to there, 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 and plus D to get to there. So our equation then will be 16 plus, there's 5 D's, has to get us up to 46. And this will be a great way to find the D rather than just sitting here guessing, checking for 5 minutes. So we now know that the D value is 6. Now there is another way to do it. If you don't want to be so formal and you understand that all you have to do is do 46 minus 16 is 30, and then split it up by the 5 spaces in between. Sure, if you can do it that way, that's fine. Most of you guys are going to probably prefer the formal way because it gives you a process to go by, but you can also do it the informal way and you won't lose any points. Okay, so once we know that the D value is 6, now we can figure out all the other things we need. A1 then, I would have to go backwards. So I'd have to subtract 6 twice to get to the first term. So 16 minus 6 is 10. 10 minus 6 is 4. So we now know that A1 is 4. Now to get to A25, again, I could keep on adding 6 from our 8th term here. Or, real much easier, I can start with my home base number 4. And I know that I'm going to add 6 24 times. Okay, so that will be 148. And then our formula that represents this, that's our A sub n. That means any number in this sequence can be gotten by starting with 4 and adding on 6. The number of times is the number of numbers, take away 1. All right, our next problem is our geometric. So this means that we are multiplying the same number each and every time. So we have A3 is 50. And then we have A5 is 1,250. Again, I can either guess what we're multiplying and try to do it that way, or I can set up something to help me. So I'm going to do it that way. I know that I have to multiply by R to get to this one, and I have to multiply by R to get to this one. So my equation basically is 50 times R is R squared equals 1,250. So if I do it this way, much easier. I'm going to divide out the 50. So R squared equals, I'm going to divide this one. So R squared equals 25. And that means I take the square root, and the R value is 5. So I now know that I am multiplying 5 each and every time. So if I'm going to go back to A1, which is this one right there, I know that if I multiply to go forward, I divide to go back. So if I divide by 5, I'm going to get 10, and I divide by 5, I get 2. So A1 is 2. To get to A9, I know I start with my home base number. It's going to be 2. I'm multiplying 5, and the number of 5s I'm going to multiply in are 1 less than the number of terms I have. So to get to the 9th, I'm going to have 8 5s. So 2 times 5 to the 8th power. I now know my ninth term will be 781,250. And then finally, to get my formula, same thing from last time, a sub n equals my starting number 2. I'm multiplying that by 5. The number of times I'm multiplying the 5 is always 1 less than the number of numbers. So n minus 1 power. All right, we're going to just do 2 more together just to make sure you guys got it. Again, if you would like to stop and try to do these on your own first and then compare your answers, you're more than welcome to pause the video. Okay, on problem number 3, we have in an arithmetic series, a 4 is 18 and a 7 is 6. You don't have to do visuals, but I always love visuals to help you see the problem better. So A4 is 18 and A7 is 6. So notice that the numbers are going down. So you know that you're not adding a positive number, you must be adding a negative number because we are doing an arithmetic, which means that it's adding. So I know that I'm going to have to add D to get to that one, add D to get to that one, and add D to get to that one. So I have 18 plus 3 Ds has to get me down to 6. Okay, now I can solve. Okay, so I know my common difference is -4. All right, so if I am subtracting 4 to go up, I must be adding 4 to go back down. So 18 plus 4 is 22, plus 4 more is 26, plus 4 more is 30. Okay, so A1 then, our first term, our base guy is 30. Okay, now from there, I can get anything I want now. So to get to the 20th, I know I start with my home base guy, 30, and I know that I'm adding a -4. So you can either write it like this, or more commonly, you'll see it just written with a -4. So we are subtracting 4, and the number of times I need to subtract 4 is going to be 19. Okay, -46. All right, our formula then, a sub n is equal to our first guy, 30, minus 4, and the number 4s I need to multiply is n minus 1 times. So I have a little, in the box, I have a little way to help you remember how to set up the equation if you need that to help you. Okay, our last problem. This one again is a geometric. That means that we are multiplying to get from one number to the other number. So we're going to again do our visual. So A2 is 28 and A5 is 224. Okay, so there's our second and our fifth. So I know that I'm multiplying R to get to that, multiplying by R to get to that, multiplying by R to get to that number. So 28 times R times R times R is times R cubed. And then solve. Okay, to get rid of a power 3, either cube root it or do reciprocal power. And again, the r happens to be 2, a nice number. So if you're multiplying by 2 to go forward, you're going to divide by 2 to go backwards. So I now know that the first term is 14. And then from there, piece of cake now. 15, the 15th term, I know I start at 14. I know I'm going to multiply by 2, and the number of 2's I need to multiply is 1 less, so 14 2's. Oops, I'm sorry, I did 4 instead of 14. And lastly, our formula, a sub n. A sub n is 14 times 2, and the number of 2's is n minus 1.